Hello, algebra students. Mr. Lawrence here, and after today's lesson, you're going to be able to say, I can factor using the difference of perfect squares pattern. Now, before we actually get to the lesson, I want to do a quick review here. We know how to factor by GCF, and when should we try to factor by GCF? Remember, we should always try this first. With a lot of the big F word, this is going to make our job simpler. Sometimes we will factor by one of the other patterns that we're going to learn, but we'll miss the GCF, and it's a lot more difficult to do, and the answer actually isn't broken down as far as it can be. So we're always going to try GCF first, even though this pattern that we're learning is called the difference of perfect squares. Okay? So we're always going to look to see if there's a GCF first. Then we know how to group, and grouping, is using the GCF because it's just GCFing 3 times. Okay, but today we're going to learn the difference of perfect squares. But remember, we're always going to try to GCF first. So before we actually do a couple, let's come down here, and I think I will feel like writing in Poiple today. There we go. And let's FOIL this. I'm going to do my firsts, and I'm going to get 9x squared, right? I'm going to do my outers and get a negative 6x. Then I'm going to do my inners and get a positive 6x. Make sure to put that sign in. And then I'm going to do my last, and I'm going to get a negative 4. Now, these here are going to cancel out, and I'm going to be left with 9x squared minus 4, right? What kind of number is 9x squared? Well, it's a perfect square, and its square root is 3x. What kind of number is 4? It's a perfect square. Its square root is 2. And look at this, in both of the quantities, I have a 3x and a 2 in both quantities. The only difference is one's a positive and one's a negative. That's how these are going to factor. We're going to work backwards. We're going to have the answer to the FOIL problem. If we see a perfect square minus a perfect square, we're going to take the square roots and then we're going to stick them in the quantities. Okay, but let's do another one forwards. Let's FOIL. And here we go. My firsts are going to get me x squared, which is a perfect square, right? My outers are going to get me a negative 4x. My inners are going to get me a positive 4x. And then my lasts are going to get me a negative 16. Inners and outers are going to cancel. I'm going to be left with x squared minus 16. Perfect square. Perfect square. And remember, it's called the difference of perfect squares. Difference means subtraction. There has to be one subtraction sign. And there it is, x squared minus 16. Okay, so let's try number 3 here. First of all, ask yourself, is x squared a perfect square? Why, yes, it is. And the square root of it is x. Is 9 a perfect square? It is, and the square root of it is 3. Here's how this factors. X plus 3 as a quantity, x minus 3 as a quantity. That's it. That's it. It's called the difference of perfect squares pattern. Check out number 4. Is 36x squared a perfect square? It sure is. 36, the square root is 6. X squared square root is x. 49 is a perfect square. 7 is just going to factor as 6x plus 7 and 6x minus 7. You might realize that to get a negative for your last, you have to have one positive, one negative. I have one positive, one negative. All right, let's try number 5. Now, we're going to GCF. This one has a GCF first. I didn't show it on those, but there was no GCF other than one. Number 5, there's a GCF hiding in here. I think an 8 goes into both of these. I'm going to factor out an 8. And remember, the 8 doesn't go away. And I'll be left with x squared minus 9. And then inside here, this is a perfect square. The 9's a perfect square. So my solution is going to be 8 times the quantity of x plus 3 times the quantity of x minus 3. And there you go. Number 6 also has a GCF hiding in it. I'll bet you know it's 5. I'm going to divide by 5, which causes me to pull that 5 out. Oops. Let me undo that. There we we go. There we go. That's what I'm trying to do. And so I'm going to pull that 5 out front. I'll be left with an x squared minus a 25. And then I'm going to say, is x squared a perfect square? You bet your boots. Is 25 a perfect square? Sure is. So I'm going to get 5 times the quantity of x plus 5 times the quantity of x minus 5. Now I'm going to try to trick you. Let's see if you can factor this one. Let's do x squared plus 4. Okay. Well, is x squared a perfect square? Yep. Is 4 a perfect square? Sure is. Some of you might be thinking, oh, it'll be x plus 2, x minus 2. And I disagree. Because when I do my lasts, I'm going to get a negative 4, aren't I? I need a positive 4. That does not work. Oh, okay, I know. It must both be the same. X plus 4 times x plus 4. That'll give me a positive. Oh, I'm sorry, 2 I should be saying, not 4. Sorry about that. X plus 2, x plus 2, just like that. So I'm going to get a positive 4 for my last. The only problem is, with my outers and my inners, I'm going to get 2x and 2x. That makes 4x. Is there a 4x in this problem? No, there's not. I hope you see what I'm getting at. This one can't be factored because it's not the difference of perfect squares. There's no subtraction. It can't be factored. No subtraction. So this one we would say is prime. Okay? Now let's do 2 more. Again, I'm trying to trick you on these. Let's go here. We'll do an easy one. Let's do 9x squared minus, oh, let me see here, 36. Do that one. And this one here is going to be 10x squared plus 250. And then one more will be, let's go with 28x squared, negative 28x squared, plus 63. Okay. So why don't you pause the video, see if you can do these. If you can do these, feel really good about yourself. They're a little bit harder. Give them a try, and then unpause the video when you're ready to see my solution. Okay, first thing I'm going to do is GCF, right? So we're looking for the GCF of these two numbers. I'm on number 1. Okay, it's going to be a 9. So we have a 9 out front, and that's going to be an x squared minus 4. I have a perfect square divided by, oh, excuse me, subtracting a perfect square. So this will factor as 9 times the quantity of x plus 2 times the quantity of x minus 2. That should be pretty simple. Okay, come on to problem number 2. Let's GCF it. I see that 10 goes in here, and 10 also goes in there. I pull my 10 out, I'm left with x squared plus 25. I have a perfect square, but there's no subtraction. So I stop right here. I don't say it's prime because I actually pulled out a GCF. But that's all I can do to it. Okay, let's slide down to this one here. Let me give myself a little bit more room to work. I see a GCF hiding in there. You might not see it, but it's in there. There's a 7. 7 can go in there. All right, and I'll pull my 7 out. I'll be left with a negative 4x squared plus 9. All right, do I have a perfect square here? I sure do. Do I have a perfect square here? Yep. But you're thinking it's not subtraction. Well, wait a minute. Isn't negative 4x squared plus 9 the same as 9 minus 4x squared? Yeah, I'm going to rewrite this over here. 7 times the quantity of 9 minus 4x squared. You still think it's not subtraction? Subtraction means one of the terms is negative and one of the terms is positive. That's what a subtraction problem is. 5 minus 3. Is one of the terms positive? Yep. And one of them's negative. Negative 3 plus 5 is a subtraction problem. is one of the terms negative and one of the terms is positive. Okay, so I know the square root of 9 is 3 and the square root of 4x squared is 2x. So this will factor as 7 times 3 minus 2x times the quantity of 3 plus 2x. And there you go. Pretty easy stuff. All right, we're going to get some practice with this class tomorrow. Mr. Lawrence signing off. Good night, everybody.